Okay, hey guys. So we're moving on now to the cosine law. It's gonna be kind of similar to the sine law, I guess, where it's still gonna be with non-right triangles. So we got A, B, and C, like in this acute triangle on this side, and straight across from it, just like before, we're gonna have the side lowercase a, and then straight across from the B will be lowercase b, and then lowercase c on that side. So that all looks the same, but now we just have a new formula that we're going to use. So it's going to be this one. I know it looks really confusing, but all we're really doing is we're going to plug in, um, A into spot A, B into spot B, and so on, right? It's going to be the same thing whether you have an oblique triangle or an acute triangle. But we have a little bit different formula for when we're solving for the angle. But that's about it. It's going to be the same thing again. So if we move on down here. Okay. So there's going to be two situations when we use the cosine law instead of the sine law. And that's going to be when we have, right here it says SAS. What that means is side, angle, side. So that's what that means, right? So that's going to be a situation like this, where we've got a side, an angle, or sorry, another side, and then an angle in the middle, right? So side, angle, side. Yeah, so if you see that type of thing where there's like an angle sandwiched between two sides like that, that's going to be when we use it. Because we can't use sine law for this, right? Because I don't know like m and little m. I don't know the ratio, so it just won't work if you try to set it up that way. So now that we know that, what we're going to do is just write down cosine law. So if that's my cosine law up at the top. Now you might see that down here we've got n's and m's and p's instead of c, a, and b. That doesn't really matter, right? So let's say that I'm looking for, I'm just going to fill in the missing things here. So this would be side lowercase m. This would be side lowercase p. I guess it should be more lowercase than that. And this would be side lowercase n. So if I'm looking for side lowercase m, right? Let's just call that's going to be like our c. So I'm going to rewrite this as m squared is equal to, now it doesn't really matter if I go n squared or p squared first, just one of the two, doesn't matter. So I'll go, I don't know, p squared plus n squared minus 2, and now again just p and n, and then the cosine is always going to be the cosine of the letter that I'm looking for, but the uppercase one, right? So cosine m. And that's it. Now we just got to fill it in. So if you fill that in, you get all of this. Make sure you guys just try putting this all in. The only thing I'm thinking is that you might make a mistake just with your order of operations or something, like if you put in your calculator wrong. So make sure you're able to put this in your calculator. If you can't, come see me and figure out what's happening. But if you put that on your calculator, you end up getting 1,343.3904. Then what we gotta do is just take the square root of that, right? So m in the end would just be equal to 36.7, and our units were in centimeters, so better 8 centimeters. Okay, so that's how you do those questions. Really just like using the formula, plugging stuff in. So this one's pretty straightforward. I think the biggest thing is just knowing when to use it. So I'm going to let you guys go ahead and give these ones a try here. But I'll just quickly show you the last situation. So we got two situations where we do cosine law. The other one is when it's going to be just side, side, side. So these are all sides, right? So now the only problem with this one though is that on your guys' formula sheet you don't have the rearranged formula for this. So two things, you can memorize it, or I could show you how to figure it out. Okay, so if you start off with your just a whole original formula, right? What we're looking for is one of the angles. So, and we're looking for angle A in this case. So we're looking for this, right? We want cos A on its own. So what we're going to do here, first off the bat, just to make things easier, is I'm going to just swap this and in this, right? I'm going to bring negative 2bc cos A, this whole term, I'm going to bring it over to the left-hand side of the equation. It'll be positive when it goes over there, right? And I'm going to bring a squared over to the right side of the equation. I'll subtract a squared. So I'm just swapping those two is all I'm doing first. So you'd say, now I have left 2bc cos A is equal to b squared plus c squared minus a squared, right? That's the a squared I brought over. Now I just need to get cos A on its own, right? So all I'm going to do is divide both sides by 2bc, which really just means I'm going to bring those down to the bottom of that side of the equation, right? And what I have left when I do that is just cosine A is equal to b squared plus c squared minus a squared all over 2bc. And now it's not any tougher. Now we just got to plug stuff in, right? So we just got to plug in what we know. So if I finish this, we've got cosine A is equal to b was 10 squared plus, and c was 16 squared minus a was 14 squared all over 2 times b was 10, c was 16, and we got cos A is equal to, and now you could write this as a decimal, but I'm just going to keep it as, you know, the top part of the equation over the bottom part of the equation would be 160 over 320. Doesn't really matter. You could actually divide those two in your calculator and put it as a decimal as well. Now the next step, just remember your calculators, if I want to figure out what A is, I have to go A is equal to cosine, and then that -1 symbol, like the inverse of cos, right? Cosine -1 of 160 over 320, or the decimal if you ended up making that into a decimal instead, doesn't matter. And then put that into your calculator. Make sure your calculator is in degree mode, or else you'll get like probably a decimal as an answer here. So make sure it's in degree mode, and if you do that, you end up getting 60 degrees. And unlike the sine law, there isn't going to be an ambiguous case here. So these ones are kind of more straightforward, where your answer is 60 degrees.